One of the problems facing customers today is the time it takes to get data from source systems to business insights. It often involves lots of manual effort by teams of valuable engineers. In today's video, we're going to discuss DataOps and how it can accelerate the time to generate business insights and lower the cost in doing so. As you might have guessed, DataOps draws from a lot of concepts in the DevOps movement, including automation, collaboration, monitoring, and observability. Let's take a look at a few examples of how we can incorporate DataOps into our analytics environments. The diagram that you see here is a reference architecture for a modern data platform that the team here at Ahead has put together. Overlaid on different parts of the architecture are technologies or ways in which we can incorporate automation and collaboration to reduce the toil in getting data through our data pipelines and ready to be consumed by different members of the business or data teams. Let's start with the data ingestion process. One of the shifts happening in the industry today is the move from ETL to ELT, where data is extracted from source systems and loaded into the data lake or a data warehouse in raw format before any transformations are done. One of the vendors focused on the extract and load phases that we think highly of is a company called Fivetran. In the same way cloud-based infrastructure can be created using infrastructure as code tools, Fivetran has a Terraform provider in the Terraform registry, allowing organizations to create their data pipelines in a similar codified way. The Terraform code can be stored in a code repository like GitHub or GitLab, managed and versioned accordingly. Next, let's talk about transformations, which is the T in ELT. A popular and widely adopted tool in the marketplace today for doing data transformations is dbt, which stands for Data Build Tool. Transformation jobs have historically been written in SQL, but the latest versions of dbt now support Python as well. One of the historical problems with ETL processes is that if business requirements change and business stakeholders need the data transformed in different ways, well, there isn't access to the raw data to easily make those changes. By storing a copy of the raw data using an extract and load process, the business can always go back and rerun transformation jobs using new and different criteria or business logic based on the changes happening in the marketplace or in their business. A data engineer can create a branch of the SQL or Python code, make the necessary changes, submit a pull request to have their changes reviewed by a peer, and once approved, have the code merged into the main branch. A fully automated data pipeline managed and operated as code. All right, lastly, let's talk about data science and machine learning. Many data scientists are coding their models in R or Python and then packaging up those models in a container format to be deployed into production. Once the model has been deployed, doesn't mean that it will be forever accurate. As market dynamics change, we get what's known as data drift. The features in a data set that were most influential in predicting a certain outcome today may not be the same features indicative of what will happen a week or a month from now. As new data comes in, we should be in the regular habit of retraining our models and challenging existing models in production to see if the new model will produce more accurate results because of data drift or other factors. In the same way that we employed a GitOps workflow to power our CI/CD pipelines for data ingestion, we can also store our machine learning models in a container registry to automate the deployment of new and more accurate models. The ultimate goal of a DataOps approach is to allow data teams to become more agile and more responsive to the changing needs of the business, the marketplace at large, and to customers. Thanks so much for watching.